triangles and their different angles. Well, we need to be able to classify triangles according to their sides and their angles. First of all, we're going to talk about triangles based upon their angles. Now, the first one is an equal angular. An equal angular triangle means that all the angles are congruent. So if we are looking at a triangle, and let me bring one up, that means that our triangle, all the angles would be congruent. That is an equal angular triangle. An acute triangle is a triangle where all the angles are acute. All angles are acute. That means that every angle here, here, and here are all measures of the angles are all less than 90 degrees. They're from that 0 to 90 range. Just like we classify an angle as an acute triangle would be a triangle where all angles are from 0 to 90 degrees. A right triangle would be a triangle with one right angle. And we always know that it is a right angle, the fact that we will have that box drawn in the corner to represent that we have a right angle. Now, it can only have one right angle. If it has more, we then break the theorem of the sum of the angles of 180 degrees. An obtuse triangle is a triangle with one obtuse angle. And that particular angle, our obtuse angle, falls between 90 and 180 degrees. Just like an obtuse angle, an obtuse triangle has only one obtuse angle in it. Now, the other two angles would have to be acute, just as in a right triangle as well. Triangles based upon their side measures. We have equilateral, isosceles, and scalene. An equilateral triangle is a triangle where all the sides are, guessed it, the same. We show those tick marks here. That represents that all the sides are the same measure. An isosceles triangle, at least two sides are congruent. We most often always just see the two isosceles. And the third type is a scalene. And a scalene triangle means that there are no sides congruent to each other. We could actually have measures of angles, or sides rather, sorry. We could have, this is 5, this one as 7 or 6, and the last one is 7. Numbers representing the fact that no sides are the same. If we are ever asked to classify a triangle, we could classify it using both angle and side measures. If we're given the following, a triangle with the different measures, say that we're looking at this angle, and we're told that we have the side of 9 units, this one is 6. Let's say that this side is 12 units as well. We automatically realize that that is a scalene triangle. But looking at the angle measures at first glance, which is what we never try to do in geometry because nothing is ever drawn to scale, we see that we're just told we have one angle of 100 degrees here. So, based upon its angles, it is an obtuse triangle. Now, the way that we would want to classify this triangle by its angles and then by its sides. So this particular triangle is an obtuse scalene. So always angle and then the sides is the way that we would name a triangle in that order. Today in our lesson we will be talking about parallel lines and the triangle angle sum theorem. The triangle angle sum theorem tells us that the sum of the measures of the angles of a triangle is 180 degrees. And when we're referring to the sum of the measures, or angles in this case. We will be talking about what we consider to be interior angles. If we are looking at angle X, angle Y, and angle Z. Based upon our theorem here, we are told that the sum of those three angles will always equal 180 degrees. For time's sake, we will wait until class time to actually show or prove this. For this purpose, or for this video, we will actually use that statement and apply it. Let's take the following triangle. We have triangle ABC. We are told that angle A is 35 degrees and angle C is 65 degrees. We want to know or to find the measure of the missing angle measure. In this case, it is angle B. Based upon our triangle angle sum theorem, the sum of our three angles equals 180 degrees. Now, we can either use this to represent it as X, or we wanted to call it angle B. It's up to you. X plus 35 plus 65 will equal 180 degrees. Every triangle is this way. We combine like terms. X plus 100 equals 180. Therefore, X equals 80 degrees. So the measure of angle B equals 80 degrees. Now, let's take it a step further. We have the following triangle with an additional line inside. So technically, we have three triangles here. We have the first triangle, the second one, and the whole triangle itself. We have a 65-degree angle, 39-degree. This angle here is 21 degrees, and we are wanting to solve for X, Y, and Z. Now, first thing we can do is we can look to the smaller left-hand triangle and know that we can solve for X. X plus 65 and 39 will equal 180 degrees. They form a triangle. So their sum will always equal 180. So X plus 104 equals 180. X equals 76. So if we want to, let's plug that in so we can see that in our drawing as we go. Now, we're also looking for the measures of angle Y and the measures of angle Z. If we look closely and carefully, we see that both X and Y form a line. And we know that those two angles are supplementary as well. So X plus Y equals 180. But we know X to be 76. 76 plus Y equals 180. Therefore, Y is equal to 104. And lastly, angle Z. Angle Z is in this smaller triangle here. And if we notice, we have a 21-degree angle, angle Z, and angle Y, which is now 104. We can use these two angles in Z to solve for Z. Three angles added together will equal 180 degrees. 104 plus 21 plus Z equals 180 degrees. Combining like terms, we have 125 plus Z equals 180. Z now equals 55. Let's now dig a little deeper. What if, in this particular example, we had no clue what X or Y were, and we were asked to solve for Z? Well, the way that we can look at it is we still have this angle, this whole angle, and angle Z as well. So we could use the whole big angle if need be, or a whole big triangle if need be, to solve for the value of angle Z. Now, this angle is not 39 or 21, but it is the sum of both of those. So, 65 plus Z plus these two angles. I'm going to represent it in parentheses to show that it is one angle, equals 180. Now, if we were combining like terms or solving 39 plus 21 plus 65, we would have Z plus 125 equals 180, and Z still equals 55. So there always are possibilities to find answers or solutions in different ways. Now let's change gears just for a moment. We've talked about, let's go and talk about our exterior angles for a triangle. Now, an exterior angle of a polygon, we'll talk about polygons a little bit more, but we can actually look at it and just think of it in our terms right now as a triangle if we want. So an exterior angle of a triangle is an angle formed by a side and an extension of an adjacent side. Well, here is my side, and I have taken the adjacent side and I have extended it out. Therefore, this is the exterior angle of the triangle. We know that all the other angles are inside, but we have this being our exterior angle. Now, exterior angles, we also have what are called remote interior angles. For every exterior angle, there are two remote interior angles. And these two remote interior angles are the two non-adjacent angles from the exterior angle. Why is that so important? Well, you guessed it. There's a theorem that goes along with it. And it is called the triangle exterior angle theorem. Let's move that over so we can see it better. What does it say? The measure of each exterior angle, so we're looking at this angle here, exterior angle of a triangle equals the sum of the measures of the two remote interior angles. The sum of the measures of the two remote interior angles. So what this tells us is if I have angle X, angle Y, and angle Z, since angle X is an exterior angle, and angle Y and Z are its two remote interior angles, the measure of X equals the sum of the measures of angles Y and Z. Now, most of you probably just look at it and say, well, X equals Y plus Z. That is correct. So let's put this in an actual algebraic form. Say we're told the measures of two angles. What if we are given that angle Y is, let's say that it is 80 degrees. And we're told that angle Z is equal to 60 degrees. We want to find the value of X. Well, based upon our theorem, X equals 80 plus 60. Therefore, X equals 140 degrees. I hope everything has worked out for you. Please, if you have questions, either comment on the blog or write them down, and we'll look at them the next day we get to an opportunity in class.